Sup. So I was reading this concept in chemistry which is called DD orbital transition. So simply explained, it says that an electron goes from a lower state of energy to a higher state of energy. So it gains some energy and goes up, and then it just comes back down. And when it comes back down, it basically releases the energy that it had got. So it releases that energy in terms of a photon, and a photon with some energy. That energy can be expressed as hf, h being the Planck's constant, which is a constant value, and f being the frequency of the photon. And that is how you can get color in certain, you can say, molecules or certain solutions. So that made me think, if energy comes out in form of hf and h is a constant, so maybe theoretically, if you can make something, suppose a metal sheet or a plane of water, vibrate at that same frequency, will that change colors or emit light? Well, short answer, yes. Long answer, not really. Let me explain. So, the difference being that water is a macroscopic object. When we are talking about change in color, that is about electrons, because that electron went up and came back. It released that energy that it had attained before, and that's why it gave that color. But when you're talking about a macroscopic object like water or metal, that is about its molecules and not the atoms which are shifting, not the electrons which are shifting up and down. But theoretically, you can emit light by, making the water shake at a frequency, or making the metal sheet shake at a frequency. There's just one small catch. That frequency has to be about 10 raised to 15 hertz. That's all. Like, you have to shake it at like 10 with 15 zeros, those many times in a minute. That's all. Yeah. And then apparently light just comes. So, short answer, yes, you can emit light, but it's kind of impossible. I mean, if you can do it in the lab, you can create light. So, the next time someone says God arrived and light came, you can just shake light out of anything. That's all. Bye bye.